MED is DSP based Sinewave inverter with static changeover up to 10 kVA. This is a single phase inverter DSP based design using DSPIC 30F3010 from Microchip, which is the heart of the circuit. The mains to inverter and inverter to mains changeover is happening using the IGBT switching, not using conventional relay method. Because we are using static changeover, there is no changeover time delay. These are self-powered driver modules. This module has built-in isolated power supply -8 volt plus 16 volt. So there is no need to provide an external isolated supply. These are IGBT modules of 200 ampere each. With this complete configuration and a 10 kVA transformer, this will be a complete 10 kVA unit. At present, we are using a transformer of 3 kVA, which is only for demonstration purpose. The IGBTs are fixed on the heatsink and the temperature sensor is connected to the control card. When the heatsink temperature reaches the set value, the fan will be switched on and the fan will be switched off when the temperature reduces to the preset value. The on-off control of the fan is done using a triac. The IGBTs are connected to the primary of the transformer. This is the battery connection. This is going to the secondary of the transformer. This CT is for the primary current sensing. This is MEDI's DC CT for battery current sensing. This is the CT for no load and output current sensing. This is the CT for mains current sensing. This is for AC input. This is for AC output. Channel 1 of the oscilloscope is connected to the output, the secondary of the transformer. Channel 2 of the oscilloscope is connected to the primary of the transformer. Channel 1 yellow is the output and channel 2 blue is the primary. Let us switch on the inverter. You can see the soft start at the output. During soft start, you can see the PWM in blue is increasing, and at the same time the output voltage in yellow is also increasing. The LCD will display all the parameters such as battery voltage, AC input, charger status, bypass status, load, etc. Inverter has all protection against overload and short circuit. The output is connected to 4000 watt halogen lamps, which will take high surge at the starting, nearly 40,000 watt starting surge. Let us switch on the halogen lamp. You can see the battery current in the clamp meter. During surge load, cycle by cycle current limiting will protect the IGBTs. During short circuit also, the cycle by cycle current limiting action will protect the IGBTs. The system will not immediately trip during short circuit. It will trip only if the short circuit remains more than 3 seconds. This will help in the starting of surge loads. The inverter to mains and mains to inverter changeover is always synchronous with mains. Channel 1 of the oscilloscope is connected to the AC output. Channel 2 of the oscilloscope is connected to the AC input. Channel 3 of the oscilloscope is connected to the changeover IGBT gate drive. And the oscilloscope is triggered with this, so we can capture the waveform during changeover. The inverter is switched on. Let us see the changeover from inverter to mains. Blue is the AC input, yellow is the AC output, pink is the changeover IGBT gate drive. The oscilloscope is in single shot mode, so we can capture the changeover waveform. Now the AC mains is on.
now the waveform is captured. That yellow, you can see the yellow is the output waveform. So in this portion, this much portion is the inverter, and here only the mains. This blue is the mains. When the pink is low, then the inverter mode. This is inverter mode. Here you can see the join. That is, I will zoom here. You can see here that pink I will move. See, that is, we cannot see. This is inverter and this is mains. There you can see that we cannot understand that really this is the join. So this is synchronous with the mains. So what I will do, I will reduce the mains voltage, so you can understand this mains voltage reduce inverter, so you can see the join little more clearly. Now you can see the inverter to mains changeover. See, the mains voltage I kept little low. This is inverter, this is the mains. Here only I told earlier changeover is happening. So I will do one thing, I will reduce the time base. So again I will capture that inverter to mains changeover. Now I switched off the mains. Again I am switching on the mains so that you can clearly understand. See, now this is inverter, this is mains. Where is the changeover time set? See, here is it exactly synchronous. See the yellow. The mains voltage at blue I am taking, see the blue. Here is the inverter and this is the mains. See, there is no change over time. Now I am showing from mains to inverter. Now it is in mains mode. So I am going to switch off the mains. You see that falling edge, I am triggering in the falling edge. Earlier it was in the rising edge. So now I am switching off the mains. See, this is the mains and mains failure. See, the blue is the mains, here mains failure. Then see the inverter start from the same point. Once again I will again. Now I switch on the mains and it bypass to mains. Then again I will switch off the mains. See, now I am switching off the mains. See, this is the main switch off. Then the changeover is happening. You cannot see again I will reduce and the time. Again I will. Once again I switch on. Now it will change to mains. Then after that I will switch off the mains. See, now I am switching off the mains. See the changeover. Now it is in the mains mode. I am going to put the CRO in single short mode. Now is single short. I am going to short circuit in mains mode. See the CRO, the short circuiting time. See, here the short circuit happened. Then immediately, that is this pink, you can see the pink immediately tripped. See, the mains waveform also, the short circuit, that time this mains waveform short circuit happened. Then immediately it tripped and inverter started. Then immediately inverter started. Now it is in the mains mode. Now I am going to short circuit. Before that I am putting the CRO in single short mode. So the short circuit time that will capture, you can see this is the falling edge that triggered. Now see that I am going to short circuit. See, now I short circuited, that time you see, here only the short circuit happened. Then immediately the tripped. This pink waveform you can see that immediately tripped. Then this is the mains tripped immediately and inverter soft start. See, this is the inverter soft start mode. So this portion, this pink is high, that time is the mains. This is the mains bypass. This point short circuit happened. Then immediately the mains changeover IGBT tripped and here inverter soft start. At that time mains is present. Here mains is present but mains disconnected from the short circuit and here inverter smooth start.